Let's do some examples out of section 3.2 in our textbook. These problems start on page 465. I want to start with 22 through 32 even, where we're just asked to evaluate some expressions without using a graphing calculator. So I'm given the log base 7 of 49. Well, I remember that logarithms are exponents. So the log base 7 of 49 is asking me what power I raise 7 to get 49. Well, 7 squared is 49, so that must be 2. 24, the log base 3 of 27. Same idea. What power do I raise 3 to get 27? Well, 3 to the third is 27, so that must be a 3. Log base 6 of 1 over 6. Well, what I'm thinking here is if that was just a 6 in there, right, that'd be a 1. I raised 6 to the first power. Well, it's a reciprocal, so it must be a minus 1 to send that 6 to the bottom. Going right along to number 28. The log base 3 of 1/9. Well, again, it's a reciprocal, so it's going to be a minus. Now I just need to think about what power would get me the 9, and that would be a squaring function. So 3 squared is 9, so 3 to the minus second is the reciprocal 1/9. Number 30 involves a square root. Well, what I want to do is remember that a square root is a 1/2 exponent. Okay, so what power do I raise 6 to get 6 to the 1/2? Well, that's just 1/2. And finally, 32 combines two different ideas here. 1 over the square root of 3. Well, if it was just root 3, it'd be 1/2. Since it's reciprocal, that must be a minus. All right, so that gets us through the first batch of problems that I wanted to do from 22 to 32. That leaves us just 3 more problems that I want to work through. Number 45 asks me to do a little graphing. I'm asked to graph 1/2 to the x and log base 1/2 of x. Well, those are inverse functions of each other. So really, I'm just going to think about graphing 2 inverse functions. But I'll plot points for both just to, get as much information as I can. So for the exponential function, well, I'd like to plug in -1, 0, and 1 when I'm graphing an exponential function. And I'd get out a 2, a 1, and a 1/2. For the logarithm, g of x, well, I like to plug in the base. I like to plug in 1, and I like to plug in the reciprocal of the base, 2. And what I see is that's these values that used to be y's because they're swapping places. All right, the log base 1/2 of 1/2 is 1. The log base 1/2 of 1 is 0, and the log base 1/2 of 2 is -1. Well, I have the same 2 tables of values, just with x and y changed, and these are written in a different order because I wanted the x to be increasing. But let's just graph both functions. I'm asked to use the same set of axes, so I will. -1, 1, 2, 0, 1, and 1, 1/2. There's my exponential decay function, f of x, so 1/2 to the x, and I have that horizontal asymptote here at y equals 0. Now I just want to graph the logarithm. At 1/2, I plot the point at 1, 1, 0, 2 minus 1. I know instead of a horizontal asymptote, now I'm going to have a vertical asymptote. All right, and those are inverse functions of each other. If I reflect through the line y equals x, I'd see them fold over on each other. This one flips up, so this part comes down, that part goes up, and the red one does the same thing. Just nice inverse functions of each other.